Can you try this question? Hello and welcome to today's class. So our topic today is Gay-Lussac Law. Now, Gay-Lussac is also known as the law of combining volumes. It states that when gases react, they do so in volumes which are in simple ratios to one another and to the volumes of the product if gaseous, provided that the temperature and pressure remains constant. Now, simply, Gay-Lussac is telling us that when gases react, they do so in simple ratios, in volumes. So let's look at this reaction. Hydrogen plus oxygen will give us water. Now let's balance the equation. This is 2, this is 2, oxygen is 2, oxygen is 1 here. So if we add 2 here, what will it be? This will be 2, and then this will be 2 times 2, 4. So you have 2 here, 2 times 2, 4, 2 times 2, 4. Oxygen is 2 here, oxygen is also 2, balanced. So what Gay-Lussac is saying is that in terms of volume, what is the volume here? 2. What of oxygen? 1. What of water? 2. In terms of ratio, what is the ratio here? 2 is to 1 is to 2. These are the volume or the ratio by which they react. This is what Gay-Lussac is just trying to explain, provided that those products are gaseous. That means that they must be in the gaseous state. This must be in the gaseous state. This is what Gay-Lussac is simply telling us. That's why we refer to it as the law of combining volumes. Now let's look at some practice questions. So let's look at this question. What is the volume of oxygen required to burn completely 45 cm³ of methane? Now let's solve. First of all, we are going to write the equation for the reaction. Now methane is CH4. This is methane. When it reacts in oxygen, what is it going to give you? Now, whenever there are some things we call hydrocarbon. Hydrocarbon are compounds that contain carbon and hydrogen only. So when you have those compounds, when they burn in air, when we say air, we mean oxygen. When they burn in air, they produce only 2 compounds, which are what? Carbon 4 oxide and water. When they burn in air, they produce only 2 products, carbon 4 oxide and water. All hydrocarbon burn in air to produce carbon 4 oxide and water. So it's going to give you carbon 4 oxide and water. Now we are going to balance the equation. Carbon is 1, carbon is 1. Please watch my video on atomic structure, because I think that was where I thought about balancing of the equation. So carbon is 1, carbon is 1, hydrogen 4, hydrogen 2. So you put 2 here. Then oxygen 4, oxygen 2, oxygen 2, 2. So oxygen is 2 plus 2, 4. So we are going to put 2 here. It is balanced. Now, what is the volume of oxygen required to burn completely 45 cm³ of methane? So what are you going to do? Now, following Gay-Lussac law, you've discovered that 1 volume, 1 cm³ of methane produced how many? Produced 2 cm³ of oxygen. Are we together? 1 cm³ of methane produced 2 cm³ of oxygen. Now, 45 cm³ of methane will give us how many for oxygen? So you're going to come to methane and write 45 cm³. How many will it produce, or how many will it require? So you are going to cross multiply. So you say 45 times 2 divided by 1, and that will give us what? 90 cm³ of oxygen is required. Isn't that simple? Okay, so let's look at this practice question. You have that 20 cm³ of carbon 2 oxide are sparkled with 20 cm³ of oxygen. If all volumes of gases are measured at STP, calculate the volume of the residual gases after sparkling. Okay, so first of all, we are going to write the equation for the reaction. So that will be carbon 2 oxide reacting with what? Oxygen to give us carbon 4 oxide. When carbon 2 bonds in air, it gives you what? Carbon 4. So we're going to balance the equation for the reaction. So you have this one, carbon 1, oxygen 1 plus 2, 3. Oxygen here is what? 2. So what are we going to do? Let's add 2 here. Oxygen will now be 2 times 2, 4. And then let's also add 2 here. So 2 carbon, 2 carbon, 2 oxygen plus 2, 4. 2 times 2, 4. It is balanced. So now we have gotten our a balanced equation. So the next thing to do is to write out the volumes or the ratios at which the reaction takes place. So we are given, this is 2 volumes, 1 volume, and 2 volume, or you say 2:1:2. Okay, so the next thing to do now is, we were given 2 values here, 20 cm³ of carbon 2 and 20 cm³ of oxygen were used. So how are we going to solve this? Now you are going to find out which one was actually used, because both of them, remember the question says we should calculate the volume of the residual gases. That means one was completely used and the other one was not completely used. So which one is that one that was completely used? That's the next thing to find out. So let's look at 20 cm³ of carbon 2. So you come to carbon 2 and put, if 20 cm³ of carbon 2 was used, that means 20 times 1 will give us 20 divided by 2 will give us 10. Are we together? So if 20 cm³ was used, you have 10 for this person. And how many of oxygen was used? 20 cm³. That means some part of oxygen was not used. Now let's also try out with that of oxygen. Assuming it was oxygen that we are looking at, 20 times 2 will give us 40, divided by 1 will give us 40. Now for carbon 2, how many were you given? 20. So do you see that it exceeded the quantity that was given? What you have here is 40, what you have here is 20. So certainly you will not use 20. You will not use 20 cm³ of oxygen. But if you look at 20 cm³ of carbon 2 oxide, you discover I gave you 10. And it is still within the values that you were given. So which one are you going to use? 20 cm³ of, you are going to use 20 cm³ of carbon 2 oxide. So if 20 cm³ of carbon 2 oxide, if 2 cm³ of carbon 2 oxide is equal to 1 cm³ of oxygen, 20 cm³ of carbon 2 oxide will give us what? 20 times 1 divided by 2. And that will give us what? 10 cm³. Are we together? Good. So that tells you that for every 2 of these, you have 1. For every 22 of these, you have 1. So if you have 20 here, you are having how many here? 10. And if you have 30 here, you're having 15 here. Is that okay? All right. So the question says, calculate the volume of the residual gases after sparkling. Now, when we talk about sparkling, we talk about production of gas. You added carbon 2, you added oxygen, you mix them together. At the end of the day, what are the gases that will remain? Number 1, the product will remain. If you mix this and this, you're going to have carbon 4 oxide. So the product will remain. And then number 2, the gas that did not finish, the residual gas, as in the gas that they did not use up. Like in this case now, we have oxygen will still remain because it was not completely used. So 2 gases will remain. The gas that was not, the unreacted gas, or the gas that remains, and as well as the products. Are we together? So with this, we are still going to find out that of our product. So the products, let's look at it. You can say 2:2, 20 times 2 divided by 2. You will still get the same answer if you do 10 times this divided by 1. So whichever one you want to use, you use. It's very simple. So for me, I would like to use 20. So 20 times 2 divided by 2. That will give us what? 20. And if you still say 10 times 2 divided by 1, it will still give you what? 20 cm³. So that means for every 20 cm³ of carbon 2 oxide, 10 cm³ of oxygen was used and 20 cm³ of carbon 4 oxide was produced. So the residual gases will be what? Residual gases will be the product, which is carbon 4 oxide 20 cm cube plus, now when you look at oxygen, it was packled with 20. So 20 minus 10, that means only 10 was used. Remaining 10 plus what? Oxygen, remaining oxygen 10. So that will give us what? 30 cm cube of residual gases. So the volume of the residual gases is what left is what? 30 cm cube. Let's look at another practice question. Okay, so let's look at this practice question. Calculate the volume of steam produced by the reaction using 10 cm cube of oxygen according to the equation. So in this question, we were given the equation. We are given the equation here. So let's solve. Now, we are going to look at the volumes of the ratio 2:1:2. So from the question, we are given 10 cm cube of oxygen. So 10 cm cube of oxygen. So we are asked to calculate the volume of steam produced. So what is steam here? This is steam. Water, steam. So 1 produce 2, 10 will produce how many? 10 will produce 10, you cross multiply, 10 times 2 divided by 1, and that will give us what? 20 cm cube of steam produced. Isn't that simple? So, can you try this question? Pause the video and try this question, and let's see your answer. Afterwards, continue watching the video to see if you got the answer. All right, now let's solve. What volume of oxygen will be left unreacted when a mixture of 100 cm cube of hydrogen and 200 cm cube oxygen are exploded in a eudiometer? All right, in an eudiometer. All right, so let's solve. First of all, we are going to write the equation for the reaction. So oxygen left unreacted when a mixture of hydrogen. So you are reacting hydrogen and oxygen, and that is going to give you what? Water. Hydrogen reacting with oxygen will give you water. So you are going to balance the equation. If you add 2 here, 4. If you add 2 here, 4. Then oxygen 2, balanced. So we are going to write out the ratio or the volume. 2:1:2. Now, based on what we're given here, we have two values: 100 cm cube of hydrogen, 200 cm cube of oxygen. Now, in a case like this, you are going to find out which one actually finished in the reaction, which one actually got finished in the reaction, and which one remained. So let's start with hydrogen. 100 cm cube of hydrogen, 100 times 1 divided by 2 will give us what? 100 times 1 divided by 2 will give us 50. Now, this 50, how many were you given for oxygen? You are given for oxygen 200. So 50 is contained in 200. Are we together? Okay. Then again, 200 cm cube. Let's look at 200 cm cube. 200 cm cube, 200 times 2 divided by 1 will give us what? 400 cm cube. So automatically, 400 cm cube is more than what you were given. Are we together? All right. Then another way you can solve this question is by asking yourself, 2 produced 1. 2 produced 1. So 100 will produce how many? 100 times 1 divided by 2 will give you what? 50 cm cube. Are we together? So you are going to use 100 cm cube because it produced 50, which is within the confinement of 200. Okay, so 100 produced 100, you have 100 given here, 50, it is within the confinement of 200. So what is the next thing to do? The question said, what volume of oxygen will be left unreacted? So from this, that means 50 was used. So 200 minus 50, the one that was unused was what? 150 cm cube will be left unreacted according to the question. So the answer to this question is what? C. Isn't that simple? Okay, so let's look at this question. 10 cm cube of hydrogen gas was sparkled with 20 cm cube of oxygen gas. Calculate the volume of residual gases. Now this question is for you to solve and drop your answer in the comment section. Now the first thing to do is to do what? Write the equation for the reaction. You have hydrogen and oxygen. What should I tell you? It's going to form water. Then you balance the equation and then impute the values. So you discover which values actually is going to work for your question. Are we together? Okay. So with that, you're going to calculate the volume of the residual gases. So solve this question and put your answer in the comment section. Thank you. We have come to the end of this class. Thank you for watching. Please do well to subscribe to our channel. Invite your friends to do the same. Thank you for watching. Bye-bye.